So good evening, everyone. I hope that I am audible to everyone. I'm Ashwani Singhania, and I welcome you to the fourth session of Statistic for Professionals. And this session, we are going to discuss about, or we will carry forward the same concept that we have discussed in the last session, that is probability distribution. So we have already covered three probability distribution in the last session, and uh, and those were the binomial distribution, the normal distribution, and Poisson distribution. So I hope that the concept of these three distribution are clear to all of you. And yes, the last session was cancelled because of some network issue. We were not able to connect to the cloud, and that's why the session was cancelled. So the fourth session will be tomorrow, is going to be now, and the fifth session will be tomorrow at 9 p.m. So let's begin with the today's session and understand the rest of the three probability distribution. So let's move to negative binomial distribution. So what is negative binomial distribution? So we know that we have already done binomial distribution and we know that what is it. But here also we are going to do the comparative study and try to understand what is the difference between binomial distribution, negative binomial distribution, and somewhere or the other, negative binomial distribution is extension of geometric distribution. So let's understand what these three actually signifies. So binomial distribution, if a coin is tossed 20 times, okay, so just remember the random event or the experiment is fixed, that is 20 times, right? And the variable, what is the probability that head comes up exactly 14 times? So what is variable over here? The probability, the success. So basically we want head, so it will be a success. So basically binomial was what? The successful and failure, these two were the possible outcome. So in this case head is the success, and the question is in which the number of time the experiment is being conducted is 20, which is fixed, and the random variable here is the particular times of success, that is head coming up over here, right? When we compare it with the negative binomial, let's see what is fixed over here and what is variable. So if coin is repeatedly tossed, so tossing the coin, that is the random experiment over here, is not fixed. In the earlier case binomial, it is 20, it was fixed, but here it isn't fixed. Okay, so what is the probability that third time head appear? So what is on the ninth toss? So what is fixed over here? Here the fix is that third time head occurs on the ninth toss. So here what we are asking is that what is the probability that the third head will appear on the ninth toss? So here number of experiment that will lead to certain number of successful event is the variable over here, x, right? So how is it different from geometric? It's very simple. In geometric distribution, what we ask that if the coin is tossed repeatedly, what is the probability that head will appear for the first time? So here the word first is important. Both are the same question, but in geometric we always ask for the probability of first success on particular number of random experiment, whereas in this negative binomial we are not considering, we may not be asking the first success, but maybe second, third, or maybe any number of success. at a particular times of random experiment, right? So I'm hope what is clear for you that what is fixed variable, what is fixed in binomial and what is variable in binomial, what is fixed in negative binomial and what is variable in negative binomial, right? Let's move forward and further understand. So the number of trials is fixed in binomial. The number of success is a random variable in this case, right? So this is how it's going to look like. So now let's come to negative. So in this negative binomial, the number of success is fixed. That is, it was the third time success we were looking for. And number of trials is random variable, right? So variable over here is what? Number of trials. It is something opposite, right? If you see, number of trials is fixed in binomial, whereas number of trials is random in negative binomial. Number of success is random variable in binomial. Number of success is fixed in negative binomial. I hope you are clear about the difference between binomial and negative. So once you see the question, you will be able to differentiate that which binomial is going to be used over there, right? So here is a small, let's go through this and then we will go to a question that explain you the concept further well. So in negative binomial, there are independent trials. One trials are not going to be affected by the previous or the next trial. Each trial result in two possible outcome, just like binomial distribution, that is success and failure. And the success, that is probability of success, is going to be fixed. It will not going to change from one trial to another. For example, if we are going to toss a coin, the probability of turning head is 50% or 1 by 2 or 0.5, right? So if we are going to toss the same coin for second time, again the probability is not going to change. Again, the probability of head turning up is 50%, right? And of course, failure, the probability of failure is the complement of uh, you know the probability of success, that is 1 minus probability of success will be the probability of failure. And x represent the trial number of our success. So here, what is x? X is the trial number for r success, which is r is fixed over here. Okay, so this is what the formulas look like, and we can also use it directly on the Excel, Python. There we will get the function and all these, the applications to calculate negative binomial. But just looking at this formula, what we are going to get is, so basically this is the formula of the first x minus 1 trial must be result in r minus 1 successes. So what does it mean? That suppose there is 10 trials we are going to, we are asking question that what is the probability that third time head will come up at the 10th trial. Okay, so it is clear that till the ninth trial, up till the ninth trial, two successes we have already occurred, right? If we are not able to get two heads at the ninth trial, the probability of getting the third head at the 10th trial is impossible, right? So it is very important that at the ninth trial we have to get two successes or two heads, and at the 10th what we are going to get is the third head. Okay, so we are asking for the probability. So the probability of getting R minus, R is the number of successes required. So R minus 1 successes at X minus 1 trial. So this is the probability, that is the combination of probability R minus 1 under bracket 1 minus P under bracket raised to power X minus 1 minus R minus. So this is a formula. We are going to get the X trial must be success, which has probability of, sorry, so this is the probability of getting, just considering the last example here, the probability of getting 2 heads in 9 trial, right? So now we have to calculate the probability of getting, third head at the 10th trial. So the third head we are going to get at the probability of P. So let me explain you by writing down the formula, so it will be easier for you to understand. I hope it's making sense. If you have any query in between, you can ask me, I can explain it to you. Okay, so actually this is the formula for the same what we are doing right now. So let's not erase it, because we are going to use it very soon, just like in a couple of minutes, and try to understand it over here. So what I'm asking, that what I'm saying is that if we want three heads in 10 trials, right? So when it is possible to get the third head in 10 trial, only when we have already got 2 heads at 9 trials, right? Only then it is possible, there will be a probability that we will be getting the last, that trial, that is 1 head at the 10th trial, right? So you can also see this particular part as what is the, so here the 10th trial is an independent trial, and what is the probability of it, of getting head at that 10th trial, is of course the probability of head turning up, that is 0.5, right? So let's see, what I'm going to explain you over here is that so the first X minus 1, so I've already explained you this, that this is the probability for the second success till 9th trial. Okay, so now to this we need to multiply the probability of appearing third head on the 10th trial, and that is P. So the final formula is going to be P multiplied by this particular, the last one, formula, and then finally we are going to get this formula on solving this equation. So this, the final formula for negative binomial will be the combination of probability raised to power r multiplied by 1 minus p raised to power x minus r, right? So just we have to see this formula. What is x? X is the number of trial, r is the, so x is the number of trial which will be variable in our question, r will be the fixed success, p will be the probability of success, and r will be of course the number of successes, and 1 minus p is the probability of failure, and x minus r. So this is the formula. Let's see one question based on this. Am I audible to everyone? You can see my screen. Yeah, I hope that it's audible, right? So move let's move further in our discussion. Yeah, so the question is, a person conducting a telephone survey must get 3 completed survey before their job is finished. On each random dial number, there is 9% chance of reaching an adult who will complete the survey. So we can point out over here that the what defines success over here? The completion of the survey, right? And the probability of success is 9%. The final question is, what is the probability that third completed survey occur on the 10th call? So third is the fixed number of success, right? So this is will be the R, and 10th is the random variable X. So applying the same formula, this one, the low one, just look at this formula. So this was what I was talking about. So this is the formula which I was talking about. So applying the same concept to that. So I hope that you can solve it like this, or should I solve it for you? Well, no problem. I am going to just solve it very quickly and then move forward to the next distribution. Though I have already explained you all the formulas. Let's talk about this part, because this part you can calculate by putting the value of X over there. So the probability of, so once we will get the value of this, you can calculate it. I'm just taking this part. So the probability of success is 0.9%, and the number of successes we are looking for is 3, so it will be raised to power 3, and 1 minus p is 1 minus 0, sorry, this is 0.9. Yeah, so 1.0.9 will give us uh, and then this is y raised to, again here this will be x. So x minus r, that is 10 minus 3 will be 7. So on solving this, we are going to get the value of around, so this is the probability. So once you can note down the answer and just try to calculate this with this formula, and I'm sure you're going to get the same answer. So we are moving on to the next distribution now. So this is an okay. So next distribution is going to be the exponential distribution. So exponential distribution can be compared to Poisson distribution. We'll see how. So let's read it once. The exponential distribution is one of the widely used continuous distribution. So binomial, negative binomial. Okay, these are basically the discrete distribution. But here in this case, exponential distribution is a continuous distribution. It is often used to model the time elapsed between events, right? So, for example, if uh, if we if you remember about the Poisson distribution, let's do a comparative study of Poisson and exponential distribution over here. So, number of event in a time interval. That was what the subject of the study in Poisson distribution, right? So how many event can take place between two particular time interval, say within 1 hour, within 20 minutes. So that in the last case, lambda was the time the number of event that will occur in a particular time interval. That was our lambda, or mean, whatever you say. And an exponential distribution is the time between the two event, right? So what time had actually elapsed between the two event? So that is here the subject of study, right? Here Poisson distribution was a discrete one, and this is going to be the continuous one, right? So here's a small question that will further explain the difference between the two kind of distribution. If waiting line between two events are independently exponentially distributed with parameter lambda, then the number of event in 1 unit time has a Poisson distribution with parameter lambda. So what does it mean? That the time between two event is independently distributed in exponentially way, I mean exponentially distributed, then the parameter is lambda, right? We will see how to calculate that. The same distribution can be looked in the other way. And what is that? The number of event in 1 unit of time, right? So you can select a time, and between that, what number of event is going to happen, that is actually the Poisson distribution. And the parameter for is again lambda, right? So on average, you can complete 6 homework problem per hour. So we can see that here lambda is going to be 6 on the time interval of 1 hour, right? How to look at from the point of view of exponential distribution? We will see it further. So let's see once this. So the formula for Poisson distribution is lambda raised to power x exponential raised to power minus lambda by x factorial, right? So this is the formula for calculation of Poisson distribution, whereas in case of exponential distribution, we are going to use this formula for lambda multiplied by exponential raised to power lambda multiplied by x. So this is for PDF, that is probability density function, and where CDF is continuous, because this is a continuous function, so here CDF can also be applied. So here the same question which I just read here, on average you can complete 6 homework problem per hour. So looking it from both point of view, so how Poisson distribution will see that question. What is the probability you complete less than 2 questions in 20 minutes? Right, so here in lambda going to be 2, because here the time interval is 20 minutes, and in 20 minutes, because in 60 minutes we can complete 6 questions, so in 20 minutes we are going to complete 2 questions. So lambda for this 20-minute interval is going to be 2. We have already done Poisson distribution, so you might be able to understand it very easily. So we can calculate the distribution for this value by calculating the probability of completing 0 homework in 20 minutes and probability of 1 homework in 20 minutes, and then adding it up, we are going to get the probability of a probability that you can complete less than 2 problem in 20 minutes. I hope this part is clear. Now let's move to exponential distribution. So what is the probability you will complete a homework problem between 5 and 8 minutes? So here completion of homework is so basically time you are going to take. So one homework you started, or one question you have started, completed it, and just going to start the next question. Okay, so how much time you are actually taking to complete one event, right? So here how much time you are going to take to complete homework or one question. So the probability, so what is the probability that you are going to complete your homework in 5 minutes or 8 minutes, or the question is actually what is the probability that you will complete one question within 5 to 8 minutes. I hope it is clear. Exponential distribution. So let's see what is going to be the lambda over here. So here lambda is going to be the time interval you are going to take to complete homework in one particular time interval. So here per minute you are going to complete 0.01 part of the the homework, right? So 6 divided by 60. So in 1 minute of time interval you are just going to complete this particular amount of homework. That is even much lesser than one question, right? So from so taking time to complete one question between 5 to 8 minutes, the probability is going to be the continuous probability of solving the question in less than 8 minutes, and then continuous probability of solving the question in less than 5 minutes. So we are going to subtract that, and what we are going to get, let's try to understand it by graphs. So this is how the the exponential distribution is going to look like. So here it is 5 minute, and here it is 10 minute. Okay, so first we are going to calculate the probability of completing the homework in less than 8 minutes, and then we are going, so this will cover the whole entire area up till here, right, under the distribution. And then we will going to calculate the probability of completing homework in less than 5 minutes, and this is further going to cover this area. So once we are going to subtract this whole area minus this area, what we are going to left with is this area, which is the distribution of probability of doing one homework within 5 and 8 minutes. So formula we already know, we have the lambda, right? So with this lambda, here is the formula. We also know the x over here. X is 5 and 8. So we need the continuous formula. So CDF formula we are going to use. So this is going to be the formula, and then calculating it for 5 and 8, and then subtracting it, what we are going to get the probability for. Just try it. If you won't be able to solve it, we will discuss in the next class. We have one more class where we are going to discuss about majorly the different kind of model where we make hypothesis to test our the basically we examine the means of the population and try to see that whether the probability or whether our prediction is significant or not, and then we will look the regression model as well. So in next session we are going to do that. Let's check this question and try to solve it. If you want, take a screenshot. A checkout counter at supermarket complete the process according to exponential distribution with service rate of 6 per hour, right? A customer arrives at checkpoint counter, find the probability of following event. So the service is completed in fewer than 5 minutes. The customers leaves the checkout. So these are basically three different questions. So let's quickly discuss the first one. So how we will calculate the lambda over here, and what will be the x. If you want, you can just share that with me. Can anyone can tell that what is the lambda over here and what is the value of x? Calculate the probability. Well, okay, I'm going to just tell you. So here the lambda is going to be 6 by 60, the same 0.01, and x will be the 5 minute, right? So it's same, though data is going to be the similar as last question, 6 question per hour. A similar kind of question, but yeah, question is framed in a different way. So I hope that you can relate it to the real life problem, because my focus is to discuss something very similar to real life problem rather than tossing a coin and rolling a dice. Okay, so there is now the last distribution I'm going to discuss, but I'm not going to discuss in very detail. I'm just going to give you a very brief view on this, and then we'll show you a video so that you can actually understand what or how joint probability works. So what is joint probability? So we have already gone through this normal distribution. So this normal distribution actually is a kind of distribution in which we suppose that most of the data are there which help us to make prediction better. So in some cases, what happened that we have two data, X and Y, say both are normally distribution, and then we are analyzing both of the normally distributed data together. So that is something like 3D, right? So those kind of data where we are analyzing two normally distributed data simultaneously to get some, inference or prediction. So in that case, what we do is joint probability distribution or joint density function, whatever you call it, right? So let me play a small video so that you can actually see how this works. So here in this image, you can see that this is two normally distributed data. One is on x1 axis and the other is plotted on the y1 axis, right? So what are the determinants or what are the parameters of this two data, and what is the thing that is going to make a connection between these two data? What is going to make the connection is correlation. So what is correlation? So a positive correlation between two data. Suppose that say market S&P 500 is going up, okay, every day. So what is the probability? We can ask question like that. What is the probability that say particular share or say Airbus, the share of a stock of Airbus will go up, right? So there's two data, and the return on these data, that is return on S&P 500 and the return on a stock of Airbus, is normally distributed. So here we have two normally distributed data. Okay, so the return of one can be placed on x1 and the return of other is placed on x2. So if the correlation between these two data is going to be positive, it means that if S&P 500 is going up, then this particular other stock of Airbus is also going up. Whereas negative relation or correlation is when one is going up, the other is going down. And if there is zero correlation, it means that there is no relation, they both are very random, right? You cannot predict one with the behavior of other, right? So and yes, one more thing, correlation is when it is zero, there is no relation, and when it is positive one, it means that it is perfectly correlated. Both work hand in hand. Whereas negative one correlation signifies that it is totally a positive. One is going one step further, other is coming one step back. So it is perfectly. So these two are the boundaries, +1, -1, and 0 is means no relation between these two data. So we will see over here that how the correlation, when correlation between the data will change, what will happen. So by default, this particular graph is showing that there is no correlation between these two data. Then the mean for the first one, the standard deviation for both data over here by default is 0.35 and 0.35, and the mean is 0 and 0. So we are going to change this 5 parameter, and then we are going to see how this graph is actually going to look like when we are going to change it simultaneously, then how the graph will appear. I'm just going to play this video. So here we are increasing the mean of data x1. So when we are increasing the mean, what is happening, that it is moving along the x-axis, right? So when we will move the mean of x2, when we will change the mean of x2, the graph will move along the x2, right? So we can see how mean of each data will change the position of this particular pyramid like of graph. And then finally, when we are going to move the when we are going to move the standard deviation of, say, the x. Okay, so it is going to be flatter when we are increasing the standard deviation of x1, then it is expanding on the x1 graph or x1, the line. And when we are going to bring the variance in standard deviation of x2, then it will move along the x2. So you can see how when we change the parameters under this, how they are reacting. Let's now see this particular correlation. So when there is the correlation, positive correlation, it is moving diagonally on x to x1 and x2. And if I'm going to put negative correlation, then it is just going to be in the opposite side diagonal, right? So this is kind of visualization of joint probability distribution. We are not going into detail of it because again it is a part of our premium course where you will learn these complex distribution, their use, their application. So for today, let's stop over here, and in next class we are going to discuss about the regression and the hypothesis model. So I hope it is clear to you today. So if any question you can ask, otherwise we are going to end for today. Okay, then we are ending the class for today, and we'll meet tomorrow at the same time. Thank you for